All right, so this is our other section. We got about 35 minutes. We're doing good. Histograms. So, again, I'm going to fly through the lecture, slow down when we get to the homework. So, we're on 2.2, histograms. You know what a histogram is? It's a fancy name, basically, for a bar chart, bar graph. It's almost exactly a bar graph is what it is. So, key concept, a good tool is a histogram, even better than a frequency table. So, histogram is a graph consisting of bars of equal width drawn adjacent to each other, unless there's gaps in the data. So, it's a bar graph. So, histogram is a more fancy word for a bar graph. So, we're going to make bar graphs now. This section is all about making bar graphs, which aren't far from frequency graphs, which we just made in the last section. So, it visually displays the shape of the data, the center, the spread, and outliers, data that are super high or super low, not fitting with the norm. Relative frequency histogram. So basically, see how they're turning this frequency chart into a bar graph or a histogram? See what they did? See how this bar here is at a height of 11? And this bar is at a height over here of 24, the next number. And this bar is at a height of 10. And this bar is at a height of 3. And this bar is at a height of 2. See how they took these numbers? 11, 24, 10, 3. And I already got the 2 there. 3 and 2. And they turned the frequency diagram into a bar graph. It's just another way to visually display information. Histogram, bar chart. Those are the same McDonald's lunch serve times that we were looking at in the last section, right? So you can look at this really quickly. The whole purpose is conveying a lot of data quickly and easily for people to digest. If we were computers, we're not. If we were computers, we wouldn't need all this. We could just have that whole list of original numbers and just take them in and deal with them. Computers function that way, but we're not computers. We don't think that way. A big list of numbers doesn't mean anything to us, right? We need pictures and things like that. So that's why we have a bar chart. Somebody said, hey, how's McDonald's doing on their lunch times at a board meeting? The person whose job it is to present data to the decision makers could flash that on the screen, and they could quickly and easily, the decision makers could quickly and easily see, oh, usually we're right in here. You know, that's 174. That's just below 3 minutes. 3 minutes would be 180, right? Most of the time we're getting 3 minutes or better. That's good. A little bit of the time we're going above 3 minutes. They'd know right away and have a good feel for the overall picture of how the McDonald's lunch times are going, right? Make sense? Purpose of a bar chart, histogram. Common distributions. Look at that. There's a bell, huh? Basically a bell. This is uniform. It's level. We call it uniform. This is bell that's skewed to the right. We'll talk about that in the homework. And this is a bell that's skewed. It's like it's been pulled to the left a little bit, hasn't it? And so sometimes that happens in the data. They're bells with a skew. So we'll see it in the homework. Normal distribution, we talked about that. See how the bell fits pretty much. They drew that bell on top. The green is really the data. It looks pretty bellish. Skewness, like we said, that's skewed to the right positively. Like they pulled it this way, huh? They took their bell and pulled it to the right. This one, they took the bell and pulled it to the left. And there's the homework. Here we go. Question number 1. So I tried making them bigger. Anyway, so here we go. So question number 1. Heights of adult males are normally distributed. Remember, that means bell, right? That's a word for bell shape. If a large sample of heights of adult males is randomly selected and the heights are illustrated in a histogram, bar chart, what is the shape? It's a bell. Yeah, it's an easy question. Next one. Number 2. Or should we do number 2 here? Yeah, good. Okay, I did it good. I did it well here. So number 2. Histogram. The histogram to the right. The histogram to the right represents the weight in pounds of members of a certain high school programming team. How many team members are included in the histogram? So, I don't understand. Oh, these are the weights. I was confused. Thinking they weigh 5 pounds? Okay. 105 pounds. 5 people weigh 105 pounds. I'm with it now. You good? This, over here on the left, this is the frequency. This is how many people, in other words. So you see how this bar goes up to 5? That means 5 people weigh 105 pounds. 5 of the people on the programming team. 2 people, right, this bar stops at a height of 2, weigh 115 pounds. 1 person weighs 125. 3 people weigh 135. Which is 5 people weigh 145. 3 people weigh 155. And 3 people weigh 165.
22.
What's that?
Adding up the 22.
Is that what it is? Yeah. Yeah, so they're asking, how many team members? Yeah, so we just add up those numbers, don't we? We just add up the 5, the 2, the 3, the 5, the 2, and the 3. 10, 15, what is it? 10, 15, 20? Is it 20? Did I miss one?
No.
Oh, there's another 3, huh? I skipped one. Yeah, 23, thanks.
3, 6, 9, 10 with the 1.
6, 11, 14. Oh, did I skip this one? 15, 20. Is it 20? Sorry, I'm just messing this all up. 5, 2, 1. 3, 5. There's no, why did I put a 2 here? All right, is that better? It's 22, right? 20, it's correct now. You guys aren't even paying attention. You don't care. Whatever. Just add them up, Mr. Herring. Is that good? You just add up the numbers. That's how many people. There's 22 people in that study. All right, I'll move on. Number 3. Histogram to the right represents the weight in pounds of the members of a certain high school program. Did we do that?
No.
Oh, what is the class width? Yeah, how do we find that? What is the class width? What do they want me to do? Yeah, exactly. It means like how wide that is, right? The gap. How wide is each bar? That's the width of every class. So it's going to be 130 minus 110. It's 20, isn't it? Class width must be 20. So they're all 20?
120 minus what?
No, 130 minus 110. Yeah, so it's 20 for each class. See how the bars have a width of 20? So they're all 20. So the class width is 20. What are the approximate lower and upper class limits of the first one? What's the lowest weight up there?
110.
We got a 110. And the highest? 250. Making sense? We good there? Just making sure we're comfortable with the basics of doing a bar chart. What the different names are. All right. I'll move on. If you're good with that, this will be on YouTube if I'm going too fast. Number 4, table below shows the frequency distribution of the weights of pre-1964 quarters. Yeah?
For the previous question,
Yeah.
I plugged in the numbers. It's saying that I'm wrong.
And me too.
Yeah, me too.
I think
It's 21.
Okay, see,
Uh-oh. I'm messing up, huh? So what's...
30 minus 110. That's a math problem. But if you count from 110 to 130, it's 21.
Is that the answer it wants? Here, let's...
That's a pity if you don't read the whole question.
So 110.
Yeah, let's go back. Yeah, it says, I was just going too fast. It says, what are the lower and upper of the first class?
Yeah, the first chunk.
Yeah, so it just wants the 110 and the 130. 110 and 130, yes.
I was right though for the 20.
Yeah, that part was good. Yeah, that part's good. Yeah, the other part was good. Yeah, it's letting us just do that. Are we good there? Is that making sense? This class, half of it is a reading exercise, isn't it? There's a lot of words. It's a very wordy math class, isn't it? It's pretty much the most wordy math class I think you'll ever take. All right, so clarifying. That's why it's good when you guys are doing the homework as I am. All right, so let's take a look at this one. Table shows the frequency weights of pre-1964 quarters. So old quarters. Old quarters. They took a bunch of old quarters and they weighed them. See what they weigh. And here's the weights in grams. And they have some different categories. And they want us to use the frequency distribution to make a histogram. Does the histogram, is it normal or not? So first up, which of these, A, B, or C, is the right histogram, bar chart, for that data? Can we tell? So how are you going to figure this out?
The lower and upper.
That's a good idea. Yeah. So the lower and upper should be, yeah, good idea. I like that. Lower should be 1, upper should be 1. This lower looks like 1. This upper looks like 1. So far, so good. A's so far, so good. B, no way. Look, its lower's at 5. Forget it. B's out already, huh? See how the lower's at 5 and should be 1? So C looks good. That's at 1. That's at 1. So it's either A or C. That's at 1. That's at 1. So what else can we check? This is supposed to, 4 is the next one. That looks like 4.
The 6
Oh.
and 8 are different.
What are?
A has 6 in the front and C has 6 in the back where it's supposed to be.
Oh, these two?
Yeah.
Yeah, good job. Yeah, this is supposed to be the 8, and this is the 6. And here's the middle 2 12s, you know? The 12 and the 12. They have the lower one here, the 6 here, and the higher one there. Yes, you all are right at C, huh? So you just got to look careful. Just look careful. C is actually representing the data. The 8 comes before the 6. Good. So C is right. And now for the question. Does it appear to be normally distributed? Yeah, I think so. I mean, that looks like a bell to me. Not perfect, of course, but it's pretty bellish. That looks like a bell. Yeah. So I'll get probably the next screen I have the questions. Yeah, there, good. All right, I laid it out well this time. So there's the 4 options. So we want to go with, no, A and B are out. Does not appear. No, it does appear. So forget about A and B, because they say does not appear to be normal. Does not appear to be normal. It's not A or B. It's going to either be C or D. I don't know if you can read that print. C says the histogram appears to depict normal. The frequencies generally increase to a maximum and then decrease. And the histogram is roughly symmetric. Maybe.
Yep.
Yeah, I guess that's right. Yeah, and D is wrong. See how D says the frequencies generally decrease to a minimum? No, they don't go down. The bell doesn't go down. It goes up, right? So C is the right answer there. They increase to a maximum. We good? It's making sense? Questions? Right on we go. Number 5. So another table, bunch of frequencies. You just got to figure out which one is right. Oh yeah, well, yeah. Can you tell the first category's got to be 23? So A is out of there, right? This is only like what, 5? This looks like 23. Oh, this is over 25. This is something like, I don't know, 27 or something. See how it's higher than 25? So yeah, so it's B. You guys are right. It's B. We good there? It's got to be B. See how C is already wrong? It's above 25. So it's B for sure. That was easy. It's based on the first entry. Now, do the data appear to have a distribution that is approximately normal? Does that look like a bell curve? Or, I mean, that one? Does B look like a bell curve? Not at all. Not at all. So no, it has no obvious maximum? No. It is approximately uniform? Uniform would mean level. No. No, it is not symmetric. Yeah, that's true. Remember what symmetric means? Same. Sim means same. Whenever sim is on SYM, means, a bell curve is symmetric, meaning it's the same on the right and the left of the middle. So, yeah, this graph is not symmetric. It has no middle, and it's the same on both sides of the middle. It's not. All right, we good? On with number 6. The table shows magnitudes of the earthquake that have occurred in the past 10 years. Use the frequency distribution to construct a histogram. Does it appear to be skewed? So, what kind? All right. A, B, C, or D?
C.
isn't. Oh, I see. I was looking here. Yeah, you're saying C there. Oh, yeah, that's right. Oh. Yeah, that looks right. Yeah, because 13 in the first category. That looks like 13. Then 14, a little higher. Then 7, yeah. 4 and 1, yeah, looks good. It's for sure C. And then the histogram is, then we have our choice of words down there. The histogram has a longer right tail, longer left tail, appears to be symmetric. Yeah, the tail goes down. It's like it's been pulled to the right, huh? So it's a longer right tail. So the data is almost skewed to the right. Easy enough? They've just pulled it to the right. Right? It was a bell curve. They pulled it to the right. All right. So number 7. Same kind of thing. So which one is the right graph? A, B, C, or D? You got to start off with a 1, so no way on A. A starting off something over 10, huh? And so is B. B's crazy, no way. So C looks like a 1 and a 1. D looks like a 1, if you can see it. Those are pretty low. And then 6. Yeah, those both look good. And then a 13. Yeah, maybe 13. That looks pretty good. And then what? 7. That looks good. They both look good to me.
Yeah.
And then a 1 and a 2. Well, I don't understand the difference.
I think it's being together.
They both look good to me. I mean, do you guys see any differences? I don't see any obvious differences. Oh, yeah, gaps or no gaps. Yeah, are you supposed to? Yeah. What do you think? Should we put gaps there or not? What is this data even about? Low temperatures in the course of a 31-day month. Okay, so these are temperatures. So should we have gaps or not? It's not just a style thing. There's actually like a good reason to or to not have gaps between bars.
No gaps.
Yeah, no gaps, huh? Because, so the answer should be C. Because one category is right next to the next one, right? If you're at 44 degrees, you're in the 39 to 44, you're close, you're touching. The next category begins at the very next degree, 45. Well, you might wonder, when would you ever have bars that don't touch? Well, what if I surveyed everybody in the class? So the answer is C here. So what if I surveyed everybody in the class? I said, I'm going to make a bar chart, and I'm going to ask everybody your favorite color. And a bunch of people said, my favorite color is red. There was like 10 people. And then some people said, my favorite, 18 people said, my favorite color is blue. And then some other people said, my favorite color is green. There were 6 people. There would be no reason to make those bars touch, huh?
Right.
Because if you chose red, it doesn't mean you almost chose green or blue because you're right next to blue. There's no such thing. There's no reason to touch bars in categorical data. Is everybody seeing the difference? So they would make bar charts that don't touch in that situation. Good, but with numbers like this, temperatures, those bars should touch. All right, do the data appear to be normal? Is this normal? Yeah, that's like a big bell. It's okay if the bell gets real pointy or flat. It's still a bell. So yes. There's only one yes. Good. So we'll just take that yes. Take that yes and go. All right, number 8. The last digit of the heights of 64 statistics students were obtained as part of an experiment conducted for a class. Use the frequency distribution to the right, make a histogram. All right, so they've got these digits. It's kind of weird. And then they turned them into a frequency chart. So which one of those is the right frequency chart? Which one is it? So it's got to start at 14. They kind of, well, I don't know. Wait, it can't be. D's almost to 32 here. So that can't be, right? D's out? We good? So D's clearly not, whereas this looks like 14. This looks like 14. This one sort of looks like 14 also. They made the scale differently, but it still kind of looks right. Next one, 5. It's supposed to go way down. So it's not C, huh? Because C goes up. See how the next one for C goes up? So no way. 5. Does this look like 5? It sort of does. Those both look like 5. And 5 and 5. Those are supposed to be level. Oh, it's got to be B. See how those are all level? It's B. We good there? So we found it's B. Those are level, whereas these ones go up and down. These are wrong. These are going up and down. All right. So are the data reported or measured? I haven't talked about this before. You know, when you do a study and they're wondering if the data are reported or measured. Reported or measured. The last digit of the students. Reported or measured. How do we answer this question? Reported or measured. Yeah. Okay, so first off, what does that even mean? What does that difference even mean? If we were to do that study here, let's just be real for a minute. If I say, hey, I want everybody to tell me your height in centimeters, right? Tell me your height in centimeters, or I don't know, or maybe we could, let's just, tell me your height in inches. We don't know centimeters, huh? Let's just do inches. Tell me your height in inches. So if everybody was to tell me your height in inches, there's two ways you could do that. You could just report it to me. Notice you could just remember how tall you are and just figure out the inches, you know. Or you could measure it. Take an actual tape measure right now and measure yourself. And which one's going to be more accurate? Yeah, this is more accurate. If you report it, you know, you'll remember maybe right, maybe not right. You'll probably tend to round it off to a general close number. So my point is, these are rounded usually. Usually if you collect data by asking people, how tall are you, versus measuring each person, see the difference in those two ways of collecting data? You're going to get more accurate data if you actually measure them than if you just ask them to report to you how tall they are. Well, how do you know what, because we don't know what they did. We're just looking at this picture of the data, which is just a measure of their last digit, right? Last digit. So how do we know from that? Well, you see how 14 of them ended with a 0? Most of them ended with a 0. Is that going to happen if you're measuring? Just came out right on 70, 60, 50, 40, right on. Just ended with a 0 most of the time. No. Those are people rounding their numbers. That's why you're getting so many zeros. They thought, I'm about 70 inches, or I'm about 60 inches. Do you see how they were rounding? And see all the 5s they got? You know, they got a lot of 5s because people tend to round to 0 or 5. Do you see how that data looks like data that was just reported, not measured? Because there's so many zeros. What would it look like if it was measured? Well, it should be more random. It shouldn't be a whole bunch of zeros. That's clearly somebody just rounding. Is this making sense? So let's read the different words. The data appear to be reported. Certain heights occur a disproportionate number of times. Yeah, like more than they should. We got more zeros than we should. Let's read the other ones, though. It always makes me nervous when I like A right away. The data appears to be measured. No, I don't think so. The data appears to be reported. The heights occur with roughly the same frequency. No, they're not occurring with the same frequency. This one's more. Yeah, so we got it. It is A. It is A. Is that good? Is that making sense? See the difference between reported data? So that's something that you know, the job of this class, our goal in this class, is when we're done, you're a good consumer and a good creator of statistical information. So that one goes to your ability to consume. Somebody gives you a report, and they give you a bunch of zeros. A wise consumer thinks, oh, they didn't really measure these people. They just asked them, which means this data is not all that reliable. Do you see how that makes you a wise consumer of this kind of statistical information? That's what we're looking at there. All right, number 9. I think number 9 is our last one, isn't it? Number 9, fill in the blank. What distribution has a bell shape? Wait a minute, it's not any of those.
Normal.
Oh, yeah, it is. I'm sorry, I'm just not seeing the word normal. Yeah, it is. A normal distribution has a bell shape. Okay, good. Questions on any of these? We good on that?